Hello everyone, welcome to another Ask the Trainer, and today I'm joined by Noseman, by Ellie and by Dr. Sassi, and we are going to talk about modeling, some of it polygonal, others polygonal and also procedural. And before we start, I want to take care of the housekeeping, so I'm gonna show my screen here. And yeah, what you see right now is the events page on the Maxon website, maxon.net/events. If you are already on the website, you can go to news and then events. This is how you get there. And here you can see all the events that we're doing, live events, webinars. Our webinars are for free. We have Ask the Trainer. Tomorrow we are gonna have another episode of VFX and Chill. And then on Monday, we are gonna have another demystifying post-production about digital cinematography. And next Thursday, there's gonna be another episode of Max on Color. In case you wanna catch up with things that you have missed on, well, when it comes to our live events, you can always go to the Maxon Training Team YouTube channel, and here you find the recordings of our webinars. And yeah, just for you to notice, last week and weekend we've been to IBC, and the rewinds of the presentations are being uploaded or have been uploaded to the Maxon YouTube channel, not the Maxon Training Team YouTube channel, the Maxon channel. Right. So another thing that I want to talk about is certification, because yeah, Noseman and I are pretty deep in in certification. So what we want to do is we want to prepare or use these sessions to somehow prepare you for the Cinema 4D Pro user certification test if you want to do that. But even if you don't want to do it, we share a ton of valuable knowledge here. And this knowledge is based on the certification topics that you can find on the certification website. So you can unfold all of these categories. Some of them have links to them where you can get further information, be it a link to the online help or video tutorials. And then we also always want to thank you. And this is why we're offering to give away free t-shirts. And the cool thing is that we have this link to the Maxon merch shop for Ask the Trainer exclusive wear. And we also have a coupon code. And if you use that, then you would just have to pay for the shipping, and the t-shirt is for free. All right, that being said, I think we can jump to Noseman's screen. Are you ready?
No, I'm never ready, but I'll get ready.
All right.
By the way, I do nothing for your education. I do things for entertainment, and if you can learn something, that's an additional bonus. So,
that's cool.
Okay.
So
let me go down my. Yeah, go ahead.
I'm gonna throw the screen at you now.
Throw the screen at me, and we're not going to do what we're seeing here. So, throw the screen so everyone can see.
The other one.
We're not going to do yet. And now let's do something. So quickly, I want to sort of give you an overview of certain things. I'm going to talk about polygon modeling mostly, and certain important aspects of it. I'm reading my cheat sheet over there. That's why I'm not looking directly at you. So a couple of things about subdivision surface modeling, and a quick overview of how it works. And the way I usually present this is not a cube, but a plane. You create a plane, and let's go and activate the lines, which is going to be something you're going to see me doing quite a bit. I'm going to create these 3 lines or 4 subdivisions over here, make it shorter and make this editable. And what we're going to do, we're going to go to one of the side views in points mode. And we're going to put this under a subdivision surface object and just increase this to 3 and 3. Okay. And what I'd like you to see is the relationship of the polygon object. Now, first of all, we are by default, we're working in isopalms. I hate isopalms. So let me go and say in the options, it's been moved around and I always lose it. There you go. Configure all. Go to the view and turn off isoline editing. At least for some people, the isoline works. For me, it doesn't. But I'm one of those people that has reverse orbit in my navigation, so I don't know what's wrong with me. Anyhow, this allows you to see both the low poly and the generated mesh over there. So let's do this and see what's going on. The blue are the simple polygons, and the black, or I think I can add a little color here. There you go. Make it white, or make it, I don't know, this color, represents how the subdivision is working. And this is very similar to Bézier's, where you have your control points that dictate how the interpolation is going to happen. This spline here has only 1 and 1, 2 points. But imagine what you need to think about when you see control vertices. Imagine them as a polygon from here to here, from here to here, and from here to here. So 3 polygons. And although not identical, when we're talking about subdivision surfaces, we have sort of the same principle, whereas we don't have the middle point when we're talking about subdivision surfaces, but the configuration is the same. So imagine if this edge here is one of these control vertices. This midpoint here is an imaginary line that connects this one to this one, and the third one is the third one. So very roughly, you need to think about subdivision surfaces in this particular manner. Now, there are certain principles about the way they work that will help us understand what's going on. So if I have 3 points that define some sort of curvature here, and I'm going to select the edge, I'm going to add another point here, right? And you can see that the subdivision surface is continuously curving. In order to make a transition from a curved part to a straight part, there is some sort of we do need to have points in a straight line, so to speak. So let me just bring all these down to the 0 so you can see what I'm talking about. I'm going to bring everything down and do this and do that. And at the same time, I'm going to get rid of the viewport and the horizon, so there are no more lines available. So let me remove this, drag this over here. Now, what I'd like you to observe is the curvature that's happening here. It may seem a bit odd, although we have a point right there in the middle. This one here also affects the curvature that happens on this part. And the general rule is that the continuity of a subdivision surface occurs between 3 points. This one, and this one. And if we want to have a transition from a curve to a straight line, it's good to have an extra segment somewhere in the middle that will guarantee that we have a straight line after the curvature. If you go in here, you'll see it's a straight line. So remember that 3 points if you want to create a curvature that transitions into a straight line. It will become more important as we start working with various models. The simplest example I can show you for this, so I can close this subject here, is let's take a cube with 1, 1, 1 and put it under a subdivision surface. And it's basically a sphere. Although we have straight segments in the cube, the result is a sphere because we don't have 3 points in a straight line where they're all in different directions. And that is something you need to consider. If I wanted to have a transition over here to a straight line, I think by adding 2 segments here, I'm getting exactly that in this view. And that's the minimum. This is a straight line you're going to get. If you add 1 subdivision only, you get a curvature. And the higher the subdivision, the better you're going to see it. You will see that this is not a straight line. It's a parabola. So with that in mind, and remember, we need at least 2 + 1, 3 points to define a straight line. We may or may not use that information, but I thought it'd make me seem smart in order to do that. Right, so let me close this. In the meantime, if you have any questions, the typical capitalized questions, and ask those questions in the chat. So let's begin with a very, did I say very simple configuration here? I'm going to put one line, and I'm going to make this, let's say 4, and let's narrow it. I'm going to go and make 4 holes on this. I'm going to recreate something like, I don't even know where it is now. Let me find it. Whoops. Right click. It's right click and drag. Look at all that. There you go. What I want to show you in this case is, number 1, how you go about doing something simple like this. And number 2, how 2 very different polygon configurations actually give you exactly the same final model. And that's very important, because understanding this will allow you to change your strategies when you're modeling things, depending on what you're trying to do. And here I've put, for example, a bend deformer on this. And for a configuration like this, although I wouldn't apply the bend deformer on the low poly mesh, I would rather go and put it in the high poly mesh to avoid any trouble. But nonetheless, depending on what you're doing, you will prefer one configuration over the other. This one bends a bit better because it has these midlines. This one doesn't, and this has a few extra polygons. If you want to find out how many polygons your model has, and I'm digressing, but I think it's important, you press Shift-C and you type info, and you go to object information, put it in your interface. It has this beautiful generic icon. You can add a lot of these generic icons here just to mess with your colleagues. And when you select this, you can click on this to see the overall information, or how many kilobytes it has, how many objects you've got selected, and all that. But there's an automated way. When you're in component mode, when you select an object, and providing you haven't changed your HUD in the in your again configure settings over here, Shift V, just go to the HUD, and you have these total points, total edges, total polygons, total lengths, selected points, selected edges, which is this over here. So if you want to find out, this one over here has 356 points, and this one has 320. And although they're identical, one has advantages over the other, and it depends on what you're trying to do, really. Okay, let's go and recreate this. Let me go and find that one. Oh, we're going to do this as well. Right click and drag. And let's make this editable. And let's see what we can do with this. So making holes sometimes may be some sort of challenge, but now with a couple of new tools, it's very simple. The way I like to make holes on flat planes, and I'm going to remove workspace, work plane, and horizon, just that. Select these 3 points, right click and bevel, right? Good, so we have these squares. Now another rule, so to speak, about subdivision surface is that the lowest number of points that will give you something close to a perfect circle are 8. And I have a little example I'm going to show you in a second. So let's go and add a subdivision to this. Now you can see that this gets pretty messed up, but we're going to fix that using the fit circle. Now the problem I'm having here is that I want to select these 3, and of course we have 3. That's not a problem. I want to be able to move fast and have these selections ready for me. So what I like to do as a general idea is undo, select all your generic original polygons in polygon mode. Now you can always go the select. I like to have the select open, the select menu. I can store the selection, right? You don't have to, because each selection component type holds the latest selection. Now that I have this, any new polygon that's going to be added using any tool, and it remembers the previous settings, if I go here, those are the original polygons. Doesn't matter if they change configuration. And the great thing is that I can invert this. Now I have these. So just by planning, and this is the theme of what I'm trying to say, if you plan your moves, then you'll be able to move much faster. So how do we circularize these? Well, just right click and say fit circle, click and drag. We have these nice little circles here. Now we do have topological issues with the n-gons and all that. We can always go and fix these. I'm going to use these just to make them n-gons. It just makes it easier to model when I don't want to do anything internally. It will also allow me to press I for inset and do an inset, which is going to give me quads. Now, I don't care about this being broken because I am going to change the configuration of it anyway. So how do we go and resolve issues like these? Well, the cuts, the knife tools are the ones. And depending on what kind of configuration you want to create, you can just go and sort of stitch opposite points. That's interesting. I got a big gap here. Anyway, if for any reason this happens to you, you can always go and fix the mesh. It didn't happen here. I probably did something I shouldn't have. Undo. Just when you add your first line. So I pressed KK to get the line cut. Click and drag and escape. I think I didn't press escape here. Yeah, that's what I did. See, user error. So let's go back and let's fit a circle and click and drag, and we have these nice things over here. Now I can go and remove n-gons. The strategy needs to be compatible with your way of working. So you can always go select everything, right click, and remove n-gons. This is going to triangulate things so you can identify various issues if they are present. But it doesn't matter that much because as you move forward, it will, you'll be able to sort of patch things up using your selections, your polygons, and all that nice stuff. Now, I honestly have no idea why this is happening here, but nonetheless, let's quickly continue. Let me think about this. Why is this breaking for me? Something that didn't happen before. So let me try.
One thing. Well, I'm going to show something that is that is close to what you're doing. But instead of doing the fit circle for on these points with the bevel, I did it in the bevel.
Yeah, it's not perfect.
Yeah, adjusting the shape.
That's exactly the methodology I used to. Oops, wrong shortcut. So this is exactly what I used to do. What you can do, and I just undid. You go and what Jonas is trying to show. You do the bevel, and you go and you change the depth, right? It works in flat surfaces, but when we go to different types of surfaces, it actually isn't going to work.
That's true. Yeah.
Yeah. Nonetheless, because I'm going to show a more interesting model, this sort of concept of working by planning what you will need earlier, and you have your polygons, and you can invert this, and if you want to hold these, you do another store selection and so forth, so you can have a bunch of selections, or even is this one the correct one? Double click. Yep, that's the correct one. Accumulating selection sets here is not a bad thing altogether. It seems to be quite a good thing, actually. So let me move quickly to the actual more complex. So this one over here, right? And show you how much faster you can model something like this and subdivide. It's a beautiful model, really good for sci-fi and all that, by preempting all the potential issues that may occur. So this started with Platonic. Make it editable, and let's display our lines. So again, the first idea is select all, not that, select all points and bevel and do this. Then we have the problem with the selections. So let's go to polygons that select everything. I'm not going to store the selection now. I'm just going to keep it within the polygon. Then I'm going to do this. I want to add a point. Now, this is going to cause another problem, which I'm going to backtrack again. So assuming I want to do this, but now we have these very complex n-gons again, and they have no subdivision. This is not going to help us much with what we're trying to do. It is going to cause issues. So sometimes you may need to pre-subdivide your model so that you have the information you need. And the way I'm going to do this is just press US to subdivide. And because what this does, it just subdivides each edge and connects them in the middle. Now, if I do the same thing and do my bevel, then go to these, then invert them, then UZ them so they are n-gons, then I inset them, then I extrude inside, then another extrude, then one more extrude, then an inner. Now I have a beautiful model here. Another thing you may need to add to avoid these little thingies that happen here is we need to do something to flatten these. And I think in this particular case, the fit to circle gave me exactly that. So it solves so many problems using a large variety of tools, depending on what kind of thing you want to achieve. So now they're all flat because part of the fit circle is to flatten the point. So now let's do the same thing. Inner D for extrude, one more, and one more. The reason I'm doing that is I need the 3 points to create that straight line in here. And now this is going to be literally perfect. Everything is flat, and I can continue modeling to impress my colleagues with my amazing modeling talents.
I'm already impressed, Noseman.
Happy to hear that. Excellent. And there you go. We have what is this? A sea mine or something like that. You can make it walk and make it a live sea mine. Anyway, so yeah, that's part of the planning, and don't be afraid to step back, think about it, and move forward. It will become habitual at some point. So let me just close this and close this.
There are a few things where I think that saving incrementally helps. And
True.
Modeling is definitely one of these things. So I always do that when I model stuff, and I always do that when I rig stuff.
Mm-hmm.
So save incremental is definitely a good thing.
Yeah, all right, let's quickly see the rule of eights here. This is a sphere. Well, this one is a sphere over here. Let me turn this off. That's being created by a hexahedron sphere with 7 segments. You put it under subdivision surface. It looks like a circle, a sphere. There's a bit of a discrepancy right here, but honestly, who's going to see that when you render this? So there they are, right? Which one is not a sphere? Maybe it could be a bit apparent, but the closer you can get to a sphere with a minimum amount of polygons is 8, right? And it works with cylinders. So with the spheres, because it has that double sort of the subdivision surface works in 3 dimensions. But if you have something like a cylinder, this particular cylinder here, if I go to the top view, press S, you will see that the cylinder and the circle are pretty identical. It's just the size that's different. Another thing you need to remember is that the subdivision surface shrinks what we're doing, depending on how many polygons we have. So this cylinder has 8. If I increase them, you will see it expands because we have more polygons. The transition creates a much looser curve. So the actual volume of your object is going to vary depending on how many polygons you have. So keep that in mind if you're doing subdivision surface modeling. It will shrink your object, so it sort of tightens it. The fewer you have, the more tight it's going to be, as you can see here. Okay, another one bites the dust. Bye-bye. Good. So I don't want to show this. I'm done with this. That was just an illustration to, we've done the landmine. Bye-bye. It's not a landmine, by the way. I'm not going to show this yet. Right. Let's take a look at these and take into consideration a few other things about subdivision surfaces. This is a full quad model, right? A screw cap. And you will see that they all look fairly decent here. And the other ones, these ones, have some n-gon topology. This, and this, and this. I did it on purpose. They're both the same, but with a very slightly different configuration. They have these n-gons. Now, Cinema 4D handles n-gons in subdivision surfaces pretty well. So if you're staying in Cinema 4D or any software that supports n-gons, you're good to go. But there are times when you definitely need to work with quads, so you need to do a different configuration. We're going to do this model in a quick bit. When it comes to n-gons and subdivision surface support, and that applies to triangles as well, as long as the transition from a quad to a triangle happens where there's no curvature, you shouldn't have any artifacts. And that is something you need to remember overall. So something like I can take this, I can grab all these points. Let's grab all these points here. Let's rotate them. And I'm going to use polygons actually. And I can actually go here and press Control to select these polygons. And if I press L, I can set my axes. Oops, the wrong band. There you go. Let's put this under Subdivision Surface Object, and we are going to observe it in grow shading. And let's go and add some knife cuts. So it's just KK slash through it. And immediately you see that there is that thing going on there. So let me get rid. I'm going to go modeling. This kind of artifact is because we have transitions where the transition occurs or where the bending occurs. We have a triangle and an n-gon and all that kind of stuff. And that sort of, but it's not an error from the subdivision service object. It's the way it calculates things. So it's going to mess up your continuity. So if you're going to have triangles and whatnot, make sure you don't have them where the edges are. So in this particular case, if for whatever reason, let me just revert the normals because this just freaks me out. So if I really, really wanted these polygons to have this cut here, the solution is pretty simple. I'll make sure that that ends before the curvature starts. So in this particular case, I can split the model. And let me show you a nice little neat way, which was, I think it was added quite recently. When I say quite recently, in the last few years, when you're in component mode, you can cut, paste, and this is a separate, it's a separate thing. So you can sort of move it up. And I've got modeling mode, so I've lost my cursor here. Okay, there you go. So you can move it up a bit, and then we're just going to do something to tie these together in some sort of meaningful way. So let's go and do that. I'm going to go and select my edges. So get your edges here. So these as well, I can remove these. There you go. I'm pressing Control to make a copy of this, right? And I'm going to consolidate any extra points so that this line is, let's say, pure, so to speak. So let me weld, oops, undo, let's weld them here. Now, this edge, the next one, doesn't have any extra polygons. It's pure. It doesn't have a third point. It doesn't have a complex pole or anything like that. And as far as this one, I can go and remove that. Now I can use the magical stitch and sew. So move tool, shift, double click, right click, stitch and sew, and press shift and do that. And what happens now is that under the subdivision surface object, although that thing exists, the curve does not give us any artifact. So the having the transitions happen in places where you're not actually bending, which this is wrong because it's bending here. So I should have done it properly. Of course, I can go and correct it. Shall I correct it? Yeah. So let's just go and select these. And I should have had these sort of, I can use a straighten tool. I should have done something like this anyway. I'm not going to do it now, bad planning, and I'm not going to backtrack. But as long as this is a straight line, this would have worked. I'm going to get a small artifact up there, but I don't really care now. And generally, keep the transitions that bend with your subdivision surfaces to have all quads like this, so you don't get those weird artifacts. Done. And now very quickly, what is it, 30? Right, I'll do this in 5 minutes or less. New file. Let's create a screw cap. Let me show you some magical techniques I've developed over the years. Make a copy of a helix. And let's go and add a loft and put them under the loft. Now, I'm going to raise this after I've added these. I'm going to raise this up approximately there. I'm going to find which number it is. It's 100. There we go. So that's a relatively good configuration for what I want to do. Maybe you want to reduce these points or subdivisions per segment and whatnot, and make this editable. Remove these, and let's go to points mode and right click and optimize. Now the good thing with this is that I can make as many copies as I want and just stack them on top of each other if I want a second spin or something like that. And because I made it using the default size, it will, it's in increments of 100. So select them both, connect objects and delete, select point, select all, right click, optimize. Good. So let's go and see what our situation is in this particular case. Oh, and it's going 2 steps up. Anyway, I think I sort of messed up, but hey. It's backtrack. Yay! See how fast, right? Backtracking. Go here. No subdivisions per segment. That's what I wanted. Make editable. Double it up. Raise it by 100. Boom. 200. There we go. Select them both. Connect objects and delete. That's a good thing when you know what mistake you've done. Right click and optimize. Good. There we go. Now I have what I want. Now you can remove as much of it or as you. Why is it double stacked again? Oh my lord. Why is it double stacked? What did I not? Yeah, 2. Now it's correct. I only turn this one off. I just want 1 because it's going to make it easier for you to follow, although I've already destroyed that concept by just dragging you on this. There you go. Select them both. I think I got it this time. Yippity yay. Right click, optimize. Good. 1 solid model. So the good thing about this is you don't even need some accurate measurements because you can just scale it down and bring it to whatever size you want. What we are trying to overcome here is this stepping. And the reason is that this line being from a spiral goes all the way around. So this doesn't have a sort of a specific cap on top. But we're going to do something about that. I'll do something about that. So first of all, let's go and generate the thickness of this one over here. And I think we can do this by using right-click a bevel. There we go. So I'm going to create this over here. There's my bevel. Happy with that. You can go if you want to have the selection. Let's see. I had edges and I went to polygons. And very, very quickly, if you want to resolve this, the top, you can go and you can select outline or UL to select the whole top. And if the way you can move forward is make a copy of this so you have an understanding of your topology and start removing things you feel are redundant. Because now we need to get all these points up here, I want to get them on the same level. So go here and set the scale in the Y to 0. Now we know exactly what's going on here. And then you can close this little gap here and we figure out the rest as we go. So you can use the bridge tool in edge mode. We can do this. Undo, it's got selections. Let's remove the selections. I want to bridge this and I want to bridge this. And usually once you start making these things, the solution is going to, I would say, present itself in some sort of way. So select these and say UZ just to make them n-gons. And what I want to do is I don't want this to be a triangle. So again, if you want less visual clutter, you can just use Z things. And I'm going to use my knife to cut a line here, escape, then cut a line here, escape. And I have a quad over here, undo. And the way you can fix this, if you wish, is you just select the point, make sure it's pretty much where that one is. The better way is to go to the top view, turn on your snapping and grab it from here and just put it there. It's going to put it exactly in the same level. So it will do this. Watch this. Boop. Because I'm dragging it from this. And in this particular case, I have this extra n-gon up here. And if I want to remove this, this is not perfect by any stretch of the imagination. I have this extra line here, which I can get rid of. I can go and select all this and dissolve it. There you go. I have quad, quad, quad. And up here, I can just select this, make sure I have my little quads there. Then I can go and did you know that you can actually extrude lines, edges? And if you basically click and drag, by definition, it goes 90 degrees. It goes in the normal, sort of the 90 degree from the normal direction. So you can extrude edges as well. Now, we can do exactly the same thing down here, which I'm not going to do because I need to allow Jonas to say some very interesting stuff. I'm just going to select all that loop. Now, if you go here and start selecting, it's because it sort of goes all the way around, you can't select that spirally loop, but there is a way. This is the way. You select the first and the last, and then you loop select with stop at selections, and there you go. Okay, so that's how you do that. And let's go. Inner D, extrude, a little one. Now, last part, select this and select this. Deselect this and deselect this, Noseman. Right click, normal transform, normal move. Put it under subdivision surface object and then just go and do, sorry, just go and do some adjustments on your points and all that. And with this, yeah, thank you very much for watching.
All right, so that's really cool stuff. Especially those threadings are something that caused a lot of headache in the past. There's also another way how you can do threadings that I'm gonna show you in a second.
Drum roll.
First of all, let me switch to my screen and move the two of us to the side. So here we go. So there are two things that I want to show you here in this scene. First is, when I'm modeling, I always try to, or I always like to have screen space ambient occlusion activated. And the reason for that is here, you cannot really see where this one face is ending or polygon is ending and where the others here are starting, because they are like both planar and both pointing to the same direction. You don't see any difference here. You can assume it from this line here, but you don't see it. And if you go to options and screen space ambient occlusion, or SSAO, this is something that can help you visualize those gaps that you might have here. Because it wasn't clear that this edge here is straight. It could also have been like this way or so. However, so the next thing I want to show you, and I'm going to switch on lines here by hitting NB. You can find that here under display, row shading with lines. And one thing that I see quite often is that people are beveling, I wouldn't say the wrong way, but in a way that is destroying like those planar surfaces, what Noseman already mentioned actually. So let's go with the bevel deformer here. So I'm going to go down to bevel. Oh, you cannot see it here. It's down here. And choose the bevel deformer. I had the shift key pressed when I created the bevel deformer, so now it's a child. And by default, you can see that when I increase the subdivision, that we have these artifacts here in the planes. So what you should do is make sure that these bevels are not doing that. There are two ways of doing this. One is by really phone break the roundings, but this is also something you would see. The other way you can do is, instead of first creating that bevel that really bevels, is to create a bevel again, the bevel deformer is down here, I hold down Shift, is to create a bevel in solid mode. And I have this trick from my good friend Pavel Soch, who created a lot of assets for the asset browser. So you first do this, because this way you are creating like another loop on each of those planes here, but they are solid, so they won't break the shading. And then you create a copy of that one and make it a little smaller and set this one to chamfer. And now if we bring up the subdivision here, you can see that our planar parts are still intact, right? So they are still planar. So that's a really cool thing. Okay, so the next thing I wanted to show you is that you cannot only model using like polygonal modeling techniques. Since we have introduced volumes, we can also model stuff using volumes. And since we have the remesher, the ZRemesher, we can also create great meshes out of that. So let me show you how I would approach this model in particular. It also has the threading in here, and threadings are something that you can do really well using volume workflows. So let's start by creating this. We've got a few base meshes, and one thing you should always keep in mind is that the volume builder is not aware of any Phong shading, so it will always use the actual geometry. So whenever you work with primitives, it's good to crank up the segments. Whenever you have a rotation, crank up the segments. And yeah, then we can start throwing this into the volume builder. I hold down the Alt key to make it a child, and I'm going to bring down the voxel size, let's say to 1. So here we've got our cylinder. Let me go down with the segments again so you can see the problem. Here we go. You can see those faces here. And when we go up, you don't see that. All right, now I would continue with 2 cubes. Let's create 1 cube with some fillet. And let's bring up the fillet segments. Let's make this a little bit bigger, and let's just place it here. And then we create a copy of that one and place it here. And I'm not going to work really like with exact measures or exact positions and so on because of time reasons. But this is how I would do it. Make it a child of the volume builder, and then in the volume builder we have this cool list where we can choose the mode, and we can just set both of them to subtract, and now they are subtracted from the original cylinder. So we can still move them around like so, place them maybe here. We can also create another copy, and I always tend to create those copies outside of the volume builder, so I have I can adjust it without the volume needing to be updated all the time. And let me bring the bevel up a bit more, and let's place this down here, and we're going to subtract that as well. So I'm going to make it a child of the volume builder and subtract it. No, not subtract, intersect. So we're going to create the intersection of these two. So here you can already see, okay, we're getting there. Now the only thing that's left for that top part here is create a cylinder, make it Z direction, reduce the radius, bring it up a little bit, maybe increase the radius a little bit more, and let's place it down here. We're also going to increase the rotation segments, make it a child, and subtract it. And this way we can create models quite fast. So I'm going to move this down here a little bit to align the two. And now let's talk about the threading, because I'm already fine with this one. By the way, this is just volume data. We cannot render this. It's an SDF volume. But now I'm going to create the threading down here. And the way I'm going to do this is I'm going to create a tube. Let's make this a lot smaller, like so. And we can also, let me also create a fillet here, and just with one segment, and we're going to increase the rotation segments like so. And we're also making sure that we're using a radius that we can remember, in this case a radius of 40, and I'm also going to create a helix spline. So here I have the helix spline. I set the plane to be XZ, and I set the start radius to 40 because that's the outer radius of that of the tube. And I'm also going to increase the end angle. If you didn't know, all of these numerical input fields are capable of calculating, so we can just type in ×5, for example. That looks good, maybe times 1.5. So here we go. That's a good one. And I'm just gonna place it here. Maybe that's actually, it's way too much. Let me go down here and let me bring down the height like so. ×2. Here we go. And I'm gonna place it here. Right, so now let's also make these two a child or children of the volume builder. And now they are set to union, but I want to subtract the helix. So I'm going to subtract it. And now you can see that something is already happening. We've got this threading going on, but we actually need to increase the radius. And here we go, maybe just 4 or 3. So there's a lot of trial and error involved, of course. But now, even if we go down with the voxel size, like so, you can see, all right, the shape is quite good. So the next thing I'm going to do is I'm going to create an SDF smooth. And I'm just going to place the SDF smooth right beneath the helix so that the helix is still very sharp, but that the rest is a little bit rounded. That's just something I'm always doing to make stuff a little bit more round. And then we can throw this into the volume mesher. Hold down Alt to make it apparent. And here we go. That's now geometry that we can render. Like so. Okay, but as you can see, it's the topology is quite dense. And there is a way to reduce the topology here in the volume mesher, which is the adaptive slider here. So just bring it up to 1% and you can see that the mesh is clearing up dramatically. But the other thing that is really interesting is using ZRemesher. So what we can do is we can go in here and use the remesh object, make the volume builder a child of it, and then we can see that it will be remeshed. I don't want the mesh density to be 100%. Let's go down to 10%. And it's recalculating everything live, so everything is still procedural. And now you can see, okay, we've got nice topology or nice quad topology here at the threading. Maybe we can even go lower, like 5%. That's always something you have to try, how low you can go with still keeping the shapes. And the other thing we can do in here that is quite interesting is that we can steer the topology, the edge flow. And this can be done by using splines. So I'm going to create a circle spline, set it to XZ, and let's make it a lot smaller so that it's about the size of the cap here. I'm going to place it here. I'm going to place another one here, and I'm going to place another one here and rotate it by 90 degrees. Like so, make it a bit smaller. I'm just eyeballing everything here. And now I'm going to make these editable because unfortunately this flow splines section is only capable of using real splines. So I'm going to lock this the attributes of the remesh here and just throw in these flow splines. And now you can see that a lot of things have changed. So here we've got better topology. Also here you can see that the topology is much better. And this is something we can definitely make editable and yeah, use in production. We can maybe even go lower with the mesh density, but for now, that's really cool. You can play with the adaptiveness settings, and yeah, that's something that is a really cool workflow if you want to create something really fast. So and as I said, still everything is procedural. Like we can still move around these objects and place them up here, so it's less responsive because it's calculating or recalculating all the volume stuff and everything. But you can see after a few seconds we get this mesh. So it's still completely procedural, and that's something I really love about modeling with volumes in combination with the remesh object. Just make sure that ZRemesher is the algorithm that you're using. All right. The next thing I want to show you is actually something I want to create from scratch. And let me bring in these lines. And there is another thing, or there are plenty of things that you can do in a procedural way. One thing that you need sometimes is like creating small holes over a surface. And I want to show you how you can do that procedurally. One of these ways is, as I said earlier already, the Bevel deformer. Again, you cannot see it at the moment. It's down here. So I'm going to use the Bevel deformer. And I'm going to use it in points mode. And when I bring up, wait. Okay, we have to make this editable and select the points. Actually, we don't have to select the points. Let me undo this. I think I didn't pay attention here. Here we go. It's just it was just a low radius, so it's working on the plane, of course. So what we can do with this is we can increase the subdivision like so, and then just go with the depth and set it to -100, and this way we get these roundings. But now if we want to go further, actually we need to make sure that this plane has been made editable in the first place, and what Noseman already showed. Select everything, then bevel it, then make it or current state to object, like so. Go to polygon mode again, then we invert by hitting UI or by going to select and invert selection. Where is it? Here we go. No. It is in here. Come on, invert. Here we go. And then we can again like inset this and extrude and delete stuff and so on. But as you can already see, this is a destructive workflow. So I want to show you a workflow that is non-destructive. So let me create another plane here, and let me set this to be 20 by 20 or so, and let me also make, no, let's not make it editable for now. What I want to show you, oh yes, we have to make it editable, sorry. What I want to show you here is how you can use node capsules in the object manager to create this procedurally. So let me open up the asset browser, and in this case, let me go to operators, and the ones that we need are geometry modifiers and geometry selections. So I'm gonna go to list view and make this one small. And now the next thing that I need to do, like in, the next thing I need to do is to recreate all of the steps, but using these commands here, because that's possible. So the first thing I want to do is I want to create a selection. and add it to the active selection. So I'm going to use the select capsule here, or asset, or however you want to call it. And there is this selection string field here. And here you can define which polygons you want to select. I'm going to set this to all. You just type in all. Of course, you can always go to show help. So the last entry here in that context menu is the help. And here you can see all of the stuff that you can type in here. There's a lot of useful stuff in there. And now I selected all polygons and added them to the active selection. So select polygons. And then I'm going to do the same thing again. I'm going to select the points. So here we go, select points. But this time I changed the type to be points, and I want to set this to default. And default will use the selection that is currently active, or if there is no selection, it will use all points. So now we've got these two selections. So then I'm going to go to the geometry modifiers and add a chamfer. So here we go. Now you can see that this changed a lot. And now we can make the size a little bit smaller, like so. And we can increase the subdivision here. And we can also, if we go down, bring down the depth to minus 100%. In this case, the slider only goes to 0%, but you can type in minus 100. So now we've got these, right? Okay, then after we did that, you remember that we inverted the polygon selection. So let's do this. We've got the polygon selection here. Now we need to invert it. So let's go to geometry selection nodes and use the invert selection node capsule here. So, and this needs to be in polygons mode. Now we've got the inverted selection. And next we go to the geometry modifiers and inset this. So there is a thing called inset. We can add this modifier. And now you can see that something happened on those dots. And we can, of course, tell this one that we're going to use the islands. And I'm also not going to use proportional, but like a fixed number. So now we created this. Maybe a little less, like so. And the next thing is we can extrude this, like so. And we just set this one to -5, for example. And also we are going to use the islands. Here we go. You can see where this is going. And we can also, one thing that we can do here is, for example, we can delete polygons. So when we add a delete, you can see that these polygons are gone and it's still all procedural. So now what I can do, for example, is I can use the chamfer again and chamfer the edges this time. So I'm going to set it to edges mode and maybe just to 0.5 centimeters, maybe even lower. Let me see. Yeah, we need to go a little lower. So here we go. And we can increase the subdivision. And yeah, there we go. That's our procedural setup here. So we created all of these holes on a procedural in a procedural way. And a good way to show you this is when let me deactivate all of them and let me now create a selection. So I'm gonna select a few of these points. And because we set the select points to default, it's now going to use this selection. So let me bring them in again. You can see that it's now using this selection, which is pretty cool. And the other thing that is nice is that we can do the same thing, for example, on other objects. So let me just create a cylinder and let's make it a little bit smaller. like so. We're gonna adjust the segments like so and like so, and maybe even more. Here we go. And I'm gonna make it editable. And let me just select this outer, the shell, so to speak. And I'm gonna use Fong break selection for that. So this way I can select the whole thing. And then I'm gonna shrink the selection by hitting UK, UK, UK. And I'm gonna convert this into a point selection by holding down the control key and hitting points. So here we go. This is our selection. And now, in theory, when we copy these over to the cylinder, it should do the same thing to the cylinder. All right, that's already working. Let me adjust a few parameters here. We need to adjust this chamfer. This is creating the hole. So let's bring this down to, let's say, 2 centimeters. That's way better. And then the next one is the inset. This can be like 0.5. And then the other chamfer here is gonna be like a lot less. Like so. And something is still happening, so I'm doing something wrong here. There is some sort of mistake. Where is it coming from? It's coming from the extrude. So maybe the inset is too big. Maybe the inset is too big. Let me make this a little bit smaller here. Oh yeah, that's the problem. That was the problem. Now here we go. That's way better. Right, and now we created this. And it's still very procedural, or except for like the initial geometry, it's completely procedural. So now we can also like remove parts of this selection, of this point selection. So let me go to loop selection and just delete these two to create 2 lines that don't have points, like so. All right, so it's all procedural. Now we are getting these artifacts, but when we go small enough, you won't see them.
I have an objection.
Yes.
This will be a great method, by the way. The objection part was mostly a joke. Switch to my screen because I want to add one more element that I just remembered is very important in your consideration for modeling.
You've got the screen.
Excellent. So another way, because the basic concept about modeling is that you will choose the way that is better for what you're trying to do. Now, imagine this. I have a cylinder here. So this is the overall cylinder that Jonas was using. And let's say it has 32. You want 32 lines here. So what you could do, after I make a copy just so that I have all my information, and make this sort of editable, and I'm going to go and remove every polygon except for one, so invert. Then what you can do is slice this down and then slice it once in the middle. Remember that method with the little circles we did? You can go and you can select, let's say, every other one or the ones that are adjacent. So I'm just going to do these and bevel and do that. And what else do I need to do? Not the subdivision. Where am I? Oops, undo. I've lost this. So our little thing here, subdivision, and do that. Excellent. Select these. These are now the holes. Well, you can take these and extrude them or just remove these polygons. See, I didn't plan to do my selection initially, so now I have to go and manually select them. Now you can actually use the parameters, the radius and the rotation segments with a cloner. So make a cloner, put this inside, And I'm going to set the radius to 0 in radial mode because it already is offset, and just make 32 of these and connect them. So depending on what you're trying to do, so I'm going to use a connect object just to keep this rather procedural. You can do the same thing or an equivalent thing in a tremendous amount of different ways, depending on what you're trying to do. And I'm pretty sure if we sit here for a few hours, we can present to you all sorts of methods just to produce the same thing. Maybe just one line of holes, and then use another cloner to stack them up. There you go. So an extra level of procedurality. Delete everything except for this, and then take this and add it to another cloner. That cloner is going to be linear. We need to assess the height of it. There you go. So now we have this, and it's fully procedural. I need to do the division, whatever that it's going to be, 30, 29, or something like that. And now we have another system which is much higher. So you can do exactly the same thing with the same topology and all that in so many different ways. And that's one of the advantages of Cinema 4D's creative approach, that depending on how your mind works, depending on what you're trying to do, you can just select whatever you want. Yeah. Back to you, Jonas.
This is also a really, really great workflow. That's actually something I wanted to show last, but now you showed it. So we are done here. We can switch back to all of us, and or maybe just wrap up because we're already over the hour. I just noticed that. So yeah, this was great stuff, Noseman. So we covered a lot of things here.
Very interesting workflows. I prefer mine because they're sort of self-punishing. The easy stuff, the volumes and all that, I leave it for others. I want to suffer. It gives me that creative suffering that everyone. I'm just joking. Of course, I'm going to use a volume. I do actually quite a bit of 3D printing, and my process is exactly what you did. Exactly. For me, CAD programs and all that, they can stuff it. No. Volume modeling is the number one, the best way to create models for 3D printing. They're watertight. You can control, all sorts of things. Show. Did you show the adaptive? I wasn't paying attention.
Yes, I did.
Okay. I wasn't paying attention.
Yeah, the adaptive, by the way, is I even created or recorded a quick tip on that. The adaptive is quite important when you want to remesh, because the remeshing, the time it takes to remesh an object is significantly based on the input polygon count. And just by bringing up the adaptiveness to like 5% or so, you won't really see that in the model. But the remesher is much faster when you do that.
Yep.
All right. So let me switch to not this one. Well, I want to show my screen. Here we go. Yeah, let's just wrap up here. And I'm going to do the housekeeping here. So if you don't know, if you go to maxon.net/events, you get to this page where you can find all of the awesome webinars that we are doing, like Ask the Trainer, but also VFX and Chill, which is going to happen tomorrow. Demystifying Post-Production, our series this month is Digital Cinematography on Monday. And next week, on Thursday, sorry for that, we have Max on color, and then it's all like repeating, and we have a few other things upcoming, like Forward Festival in Vienna, Broadcast India, and stuff like that. All right, if you want to rewatch this webinar, or if you just want to catch up, you can go to the Maxon training team on YouTube channel. And here we have the recordings of all of our webinars. It's hours and hours of training that you can watch for free here. And also, just as a little reminder again, the rewinds from the IBC presentations have been uploaded to the main Maxon YouTube channel, so you can watch those as well. And yeah, last but not least, we want to thank you for attending and give away a free t-shirt. So if you go to the Maxon merch shop, I'm not sure, I'm just going to copy the link here and paste it in the chat. Here we go. And use the following password to get in there. I'm also going to paste that in the chat. Here we go. Then you can order one t-shirt for free, and you would only have to pay for the shipping. And I think that's it for now. Do you have any last words, Noseman or Dr. Sassi?
I think the only confusion was that we have the volume measure and then we have to remesh. And I think sometimes when I read between the lines, there was a confusion. Why do I have to mesh first something to remesh it? But it's two different processes. One depends on the other. And I think that would be pretty much all.
Yeah, so maybe I can elaborate on that again. I replied to that in the chat, but the remesher always needs a mesh as an input. And the only way of getting a mesh from a volume is to use the volume measure. So you have to create that mesh from the volume first so that you can remesh it then. You cannot just put the remesher onto the volume builder because there is no geometry yet to remesh. You first have to mesh it. Then you can play with the adaptive slider to make the mesh coming from the volume lighter, and then you remesh it to get better quad-based topology.
And I have to add one more thing to that we all three of us replied to that question and wrote the same thing in different words. And two of you explained it. I think this is settled now.
Yeah.
Okay.
All right. Okay. Cool. Thank you, everyone. Thanks, Noseman. Thanks, Dr. Sassi. Thanks, everyone, for attending. And
thanks to Michelle and thanks to Jonas.
Michelle, not Jonas. No, he gets too much exposure here.
Okay. Cool. Not
a little bit.
But thanks to Michelle for doing stuff in the background in the chat and so on. Okay.
And Ellie.
And Ellie.
And Ellie, you forgot Ellie. How dare you?
How dare I? Okay.
Bye-bye, everyone. Thanks for attending, and just go on social media and tell everyone how cool we are and all that kind of stuff. Bring your family next time. Yeah, bring your families. Your pets. Have a family dinner with all your extended, second, third cousins and uncles and all that, and each one watching from their own computer just to get the numbers up. And yeah, thank you for that.
All right. Thank you, everyone.
Yeah.
Bye.
Bye.
See you next time.